In this video, we're going to look at a couple of examples on how to simplify rational expressions. Remember, first thing we said is make sure the numerator and denominator are completely factored, and then identify the common factors in the top bottom of the fraction and simplify by canceling them out, really dividing them out. So here are two examples. First one, we have 3a cubed minus a to the fourth over 2a cubed minus 6a squared. You factor the top, you factor the bottom. So if I look at the top, I see they have a GCF of a cubed in common. So I'm going to factor out an a cubed. That leaves me with 3 minus a. So now let's factor the bottom. 2a cubed minus 6a squared. Well, numerically, the GCF is a 2. With the variables a cubed and a squared, the GCF is a squared. And so you're left with a minus 3. So to simplify from here, we need to keep in mind, what do they have in common? First thing I'm going to look at is my GCFs. They're outside the parentheses, both of them. What can I cancel out? Well, I see I have an a squared on the bottom and an a cubed on top, which means I have 2a's multiplied down here and 3a's multiplied up here. So I can cross out 2a's down here, cross out the a squared, and really that just leaves me with an a in the top. So I have a times 3 minus a over 2 times a minus 3. Now you may think there's nowhere to go from here, but there's still one more simplification process we can use. And it should stand out that you have 3 minus a minus 3. You have the same numbers, 3 and a and 3, but they're in a different order around a minus sign. What this is called, to simplify from here, is to apply your additive inverse. To switch the order of this 3 and a so it can match down here, I can factor out a negative 1. And so really, this a stays on top, but I'm factoring out a negative 1 from these two terms, so multiplied by a negative 1. And what that allows me to do is to flip the position of the terms. If I were to look at it, if I distribute this negative 1 times a is negative a. Negative 1 times negative 3 is positive 3. So by factoring out negative 1, it allows me to rotate the position of the terms. And so on the bottom, I have 2 times a minus 3. And now I can see I can cross out the a minus 3's. I'm left with an a times negative 1, which is negative a, over 2. And so that is the completely simplified rational expression. So the new concept here is additive inverse, and we're going to talk about that in a later video as well. It was just nice to introduce it here and see that if you have subtraction of a binomial where the terms are flipped in spots, you can factor out a negative 1 to get the factors to match. Let's go do another example, number 2. I have 5x times x squared plus 4x plus 3 over x minus 6 times x squared minus 9. I'm going to factor the top. This 5x can just stay. I want to factor x squared plus 4x plus 3. So I want two numbers that multiply to give me 3, add to give me 4, and that's a positive 1 and a positive 3. So the top is 5x times x plus 1 times x plus 3. On the bottom, I can't simplify this x minus 6 any further, so I'm going to leave it alone. The x squared minus 9 is a difference of squares. So the square root of x squared is x. The square root of 9 is 3. So I have one factor that's x plus 3 and one that's x minus 3. And now I just cancel out, cross out what they have in common in both the top and the bottom. I see the top has an x plus 3 and the bottom has an x plus 3. So I can divide those out, I can cancel those out, and that's all they have in common. So my final simplified rational expression is 5x times x plus 1 over x minus 6 times x minus 3. They have no other factors in common, so I just put them all together and get my simplified rational expression. And so These examples were looking at how to simplify our rational expressions by making sure your numerator is completely factored, your denominators are completely factored, and crossing out what they have in common.